Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on the equation of a line. So we're looking at y equals mx plus c. If you need any extra help on this topic, if we go to Corbettmaths and go to the videos and worksheets section, there's dedicated video tutorials there. So videos 188, 191 and 194 will be really useful videos for you. Alternatively, you can scan the QR code on the front of this booklet. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's look at our first question, question number 1. So question number 1 says, a line has an equation y equals 3x plus 4. And part A says, write down the gradient of the line. So we want to write down the gradient of this line. So remember that a straight line has got an equation in the form y equals mx plus c, where m is the gradient of the line, the steepness of the line, and c is the y-intercept, so it'll let you know where it crosses the y-axis. So part A says write down the gradient of the line. So if we have a look here, we've got a 3 in front of the x, that's 3x, so the gradient is 3, so 3. And then the part B says write down the y-intercept of the line. So this line will cross the y-axis at the number 4, so the y-intercept will be 4. Or if you wanted to write down the coordinates of the point where it crosses the y-axis, that would be 0, 4. And the coordinates of the y-intercept will be 0, 4. You could write that down, or if the question asked you for the coordinates of the y-intercept, you'd write down 0, 4. So 0 along, 4 up. Okay, let's look at our next question, question number 2. Okay, so question number 2, it says, write down the gradient of the straight line with the equation y equals 7x plus 9. So remember, straight line's in the form y equals mx plus c, where m, the coefficient of x, the number in front of the x, is the gradient of the line, the steepness of the line. So if we have a look here, we've got a 7 in front of the x, so the gradient of that line, that straight line, would be 7. And that's it, that's the gradient of that line. 7 is the number in front of the x. Okay, let's look at our next question, question number 3. So question number 3 says a straight line has got the equation y equals 4x plus 2, and we're asked to write down the coordinates of the point where the line crosses the y-axis. So we want to write down the coordinates of the y-intercept. So remember, a straight line has got the equation of the form y equals mx plus c. M is the gradient, so the gradient of this line is 4, and the c will tell us the y-intercept, it'll tell us where the graph crosses the y-axis. So because that's plus 2, it crosses the y-axis at 2. So that means the coordinates of the point where it crosses the y-axis will be 0, 2, 0 across, 2 up, and that's it. Okay, so question number 4 says a straight line with equation y equals 2x minus 5 intercepts the y-axis at the point D. So the point D is where it crosses the y-axis. And we've been asked to write down the coordinates of the point D. So here we've got this equation, y equals 2x minus 5. The gradient of the line would be 2, because that's the m, the number in front of the x. And this minus 5 will tell us where the graph crosses the y-axis. So it crosses the y-axis at negative 5. So it crosses the y-axis at negative 5, so the y-intercept is negative 5. Now we're asked to write down the coordinates of the point D, so the coordinates of the y-intercepts, that will be 0, negative 5. So 0 across, 5 down, and that's it. Okay, let's look at our next question, question number 5. Okay, so question number 5 says, circle the equation that is not the equation of a straight line. So remember, straight lines in the form y equals mx plus c. We could also have y equals a number, such as y equals 4, y equals 7, or something like that. Also, a line such as x equals 5 would be a straight line as well. That would be a straight line, that's the equation of a straight line, then perhaps a diagonal line. Y equals 4 would be a horizontal line, and x equals 5 would be a vertical line. So all of those would be straight lines. Now if we have a look here, we've got 4 equations. We've got y equals x plus 1, so that is in the form y equals mx plus c. The gradient of that line would be 1, because it's just x, which means 1x, and the y-intercept would be 1. We've got y equals 9x minus 2, so the gradient of that line is 9, and the y-intercept is negative 2, so that is a straight line as well. Y equals x squared, no, that's going to be a quadratic graph, that's going to be a parabola, the shape of it will be that U shape. So that is not a straight line, so that's not a straight line, so we're going to circle it, y equals x squared. None of these equations will have a squared in it, so it'll be just y equals x squared, that's not the equation of a straight line. And then let's just have a look at the last one. The last one is y equals 7 minus 2x. The gradient of that line will be negative 2, that's the number in front of the x, so the gradient of that line will be negative 2, and the y-intercept will be 7, so it crosses the y-axis at 7. So that is a straight line. Even though it's not that way around, you could turn it around. You could even write it as y equals minus 2x plus 7 if you wanted to, but that is a straight line. But that one's clearly not, because it's got the squared. Okay, let's look at our next question, question number 6. Okay, so question number 6 says, a line has got an equation y equals minus x plus 5. And we've been asked to write down the gradient of the line. So remember, a straight line is in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So here the gradient will be, we've got minus x. That's the same as minus 1x. We tend not to write minus 1x, we just write minus x. So the gradient of that line would be minus 1. So the gradient of that line is minus 1. So if you ever see an equation where it's y equals minus x plus a number, the gradient would be minus 1 because minus x is minus 1x, so the gradient would be minus 1. If it was something like this, y equals x plus 8, the gradient of that line will be 1 because x is the same as 1x, so the gradient of that line will be 1. But here we're asked to write down the gradient of this line. The gradient would be negative 1. Okay, let's look at our next question, question number 7. Okay, so question number 7 says a straight line L is shown on the grid below. So this is the straight line L, and we've been asked to write down the equation of that line. So it's a straight line, so this equation is going to be in the form y equals mx plus c, so y equals mx plus c. And we want to write down the equation of that line, so we need to find the gradient of the line, and we need to find the y-intercept of the line. Now the y-intercept is quite nice, it's going to be 1, but let's find the gradient to begin with to find out what m is. Now if you need a bit of a recap in terms of gradient, if you go to Corbettmaths and watch videos 189 and 190, there's really useful video tutorials there on finding the gradient of lines. So here I'm just going to recap it as if you know how to find the gradient of a line, but watch those videos 189 and 190 and they'll be really useful for you if you need a bit more of a detailed recap of how to find the gradient of a line. So if we want to find the gradient of this line, I'm going to choose 2 points on the line. I'm going to choose any 2 points. I'm going to choose this point here, the point 0, 1, and I'm going to choose the point up here, which is the point 2, 5. And I'm going to turn it into a little right angle triangle, like so. And it's a right angle triangle. And I'm going to write down the run and the rise. The run is how many squares across you're going, and the rise is how many squares up or down you're going. And the run would be how many units you're going across. So here we're going from 0 across to 2 across, so we're going 2 across. And the rise would be how many units you're going up here. So we're going from a height of 1 to a height of 5, so the rise would be 4. To get from 1 to 5, we're going up 4, so the rise is 4. And the gradient m is found by the rise divided by the run. So if we do the rise divided by the run, we'll find the gradient. And 4 divided by 2 is equal to 2. So the gradient of that line is 2. If we go across 1 unit, we go up 2. If we go across 1 unit, we go up 2 units, and so on. So the gradient of that line is 2. So that means here the m will be 2. So it's y equals 2x. Now the plus c, we just need to find out what the y-intercept is, and it crosses the y-axis at 1, so it'll be plus 1. So the equation of that line will be y equals 2x plus 1, and that's it. That's the equation of the line L, y equals 2x plus 1, and that's it. Okay, let's look at our next question, question number 8. Okay, so question number 8. Question number 8 says a straight line is shown on the grid below. So we've got this straight line, and part A says write down the y-intercept. So where does this line cross the y-axis? So the y-intercept of that line is 2. It crosses the y-axis at 2. If it asks us to write down the coordinates of the y-axis, I would write down 0, 2. But it just asked me for the y-intercept, so I could just write down 2. Or you could write down 0, 2 for the coordinates of the y-intercept. Okay, and then in terms of part B, if we go down, part B says find the gradient of the line. So we want to find the gradient of this line. And to find the gradient of a line, I choose 2 points that are on the line. So I'm going to choose this point here, so the point -2, -4. And I'm going to choose the point here, which is -1, -1. So if I make a little right angle triangle there, it's a little right angle triangle. The run, how many units we're going across, would be 1. We're going 1 unit across. And the rise, we're going up 1, 2, 3. So the rise is 3 and the run is 1. And m, the gradient, is found by the rise divided by the run. So the rise is 3, and we're going to divide that by the run, which is 1. And 3 divided by 1 is 3. So that means the gradient of that line is 3. So that's the gradient. So the gradient is 3. And then if we have a look at our last part, the last part says to write down the equation of the line. So the equation of the line will be in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So the gradient of the line, if we go back up, was 3. So it's going to be y equals 3x. And the y-intercept was 2. If we have a look at this, the gradient was 3 and the y-intercept is 2. So it's going to be y equals 3x plus 2. That's the equation of that line, y equals 3x plus 2. Okay, let's look at our next question, question number 9. Okay, so question number 9, we've got this straight line drawn on the grid and we've been asked to write down the equation of that line. So we want to find the equation of that line. So to find the equation of the line, it's going to be the form y equals mx plus c, and we need to find the gradient and the y-intercept. So let's start off with the gradient. So I'm going to choose 2 points on the line. So I'm going to choose this point here, which is the point -4, -5. And I'm going to choose this point here, which is the point -2, -3. And I'm going to make a little right angle triangle. And I'm going to find the gradient there. So I'm going to do the rise divided by the run. So the run, so we're going from -4 to -2. So the run is 2. We're going 2 units across. And in terms of the rise, we're going from a height of -5 up to height of -3. So the rise is 2 units. Notice I mentioned units and not squares because sometimes the squares aren't, these are quite nice ones where each of the squares that you go across is you're going up across by 1 or you're going up by 1. Sometimes it might not be the same scale, so it's important to remember that you're looking at the units, so how many units across you're going, how many units up you're going, and so on. So the gradient m will be the rise, which is 2, divided by the run, which is 2, and 2 divided by 2 is 1. So the gradient of that line is 1. So it's going to be y equals, now I'm not going to write 1x, so I'm just going to write x, because 1x is x. So I'm just going to write y equals x. Now I need to find the plus c part, the y-intercept. So if we have a look at the y-axis, it crosses at -1. So the y-intercept is -1. So that means the equation of that line is y equals x minus 1. And that's it. So let's write that down. Y equals x minus 1. And that's the equation of that line. Okay, let's look at our next question, question number 10. Okay, so question number 10, we've got this straight line drawn on the grid and we need to write down the equation of that line. So it's a straight line, so it's going to be in the form y equals mx plus c. And we need to find m, the gradient, and c, the y-intercept. Now the y-intercept, you can see straight away, it's going to be 1, it's going to be plus 1 on the end there, but let's find the gradient. So to find the gradient, I'm going to choose 2 points on the line. Now I'm going to choose 2 good points. For instance, I'm not going to choose this point here, -5 something, because even though it looks like -1.5, it's not going through a nice corner like, for instance, this point here, that's a good point there. -4, -1 is a good point. And I'm going to choose the point over here, which is the point 2, 2. And I could have chosen any 2 points that are quite good points. For instance, I could have chosen -2, 0, or so on, but I've chosen these 2 points here. So let's make a little right angle triangle. So we're going to go across to get the run, and we're going to go up to get the rise. And then, remember, the gradient is equal to the rise divided by the run. So let's find the run and the rise. So how many units are we going across? So we're going from -4 to 2. So we're going 6 units across there. And then in terms of the rise, we're going from a height of -1 up to height of 2. So we're going up 3 units there. So the rise is 3 and the run is 6. So the rise is 3. We're going to divide that by the run, which is 6. So we're going to do 3 divided by 6. Now this is a non-calculator question, so we're not going to do 3 divided by 6 in our calculator. You could, if you wanted to do the bus shelter method, I probably just cancel down that fraction, because I know it's going to be a fraction, 3 over 6, and if we divide both of them by 3, we get that's equal to 3 divided by 3 is 1, and 6 divided by 3 is equal to 2. So that means the gradient of that line is a half. If we go across 1 unit, we go up a half. If we go across 1 unit, we go up a half. If we go across 1 unit, we go up a half, and so on. So the gradient of that line is a half. So it's going to be y equals a half x, and then it crosses the y-axis at 1, so the y-intercept is 1, so it's going to be plus 1. So that means the equation of that line is y equals a half x plus 1. You could write it down if you wanted to, y equals 0.5x plus 1. Either one's totally fine. Okay, so let's write that down. Y equals a half x plus 1. And that's it. That's the equation of that line. Okay, let's look at our next question, question number 11. Okay, let's look at our next question, question number 11. So question number 11 says the straight line L is shown on the grid, and we've been asked to work out the equation of L. So if we want to work out the equation of this line, it's a straight line, so it's going to be in the form y equals mx plus c, y equals mx plus c. We want to find its gradient and its y-intercept. So in terms of the gradient of this line, I'm going to choose 2 points on the line. So I'm going to choose this point here, the point -2, 3. And I'm going to choose this point here, the point -1, 1. So let's make a little right angle triangle. Now the line's going down this way, so the run will be 1. We're going from -2 to 1. But this time, in terms of the rise, it's going downwards, so it's going to have a negative rise. So it's going down from a height of 3 to a height of 1, so the rise would be -2 because we're going down 2. So in terms of the gradient, m, it's equal to the rise divided by run, rise divided by run. So we're going to do the rise, which is -2, divided by the run, which is 1. And -2 divided by 1 would be -2. So that means the gradient of this line is -2. If we go 1 unit across, we go down 2 units. 1 unit across, down 2 units. 1 unit across, down 2 units, and so on. Okay, so that's the gradient of the line. So it's going to be y equals -2x. Now in terms of the y-intercept, it crosses the y-axis at -1, so it'll be -1. So that means the equation of this line will be y equals -2x minus 1. So let's write that down. Y equals -2x minus 1. Okay, let's look at our next question, question number 12. Okay, so question number 12, we've got this line on the grid, the line L, and we've been asked to work out the equation of this line L. So again, it's going to be in the form y equals mx plus c, and we need to find the gradient of the line and the y-intercept. So in terms of the gradient of the line, I'm going to choose 2 points on the line. I'm going to choose this point here, the point 1, 8, and I'm going to choose this point here, the point 3, 16, so 3 across 16 up. I'm going to make a little right angle triangle and then go up, and I'm going to find the run and the rise. So in terms of the run, we're going from 1 to 3 horizontally. So the run would be 2, we're going 2 across. And be careful here with the rise because we're going from a height of 8 up to a height of 16. So if we're going from 8 up to 16, the rise will be 8. So we're going 8 units up. Don't just assume that we're going up 4 little boxes, so it's going to be 4. It's how many units you're going up. You're going from 8 to 16, so the rise will be 8. So the gradient is the rise, which is 8, divided by the run, which is 2, and 8 divided by 2 is 4. So the gradient of that line is 4. If we go 1 unit across, we got 4 units. If we go 1 unit across, we got 4 units, and so on. So that means the equation of the line will be y equals 4x. Now we need to find out what the y-intercept will be. Well, it crosses the y-axis of 4, so it'll be plus 4. So the equation of that line is y equals 4x plus 4, and that's it. So question number 13 says a line has got an equation y equals 3 minus 4x, and we've been asked to write down the gradient of the line. Now this is a bit similar to a question we had earlier. We had a multiple choice question earlier where we had the y-intercept and the gradient of the line the other way around, because here we've got y equals 3 minus 4x. Remember, normally how the equation of the line y equals mx plus c. The gradient is the number in front of the x, so the coefficient of x. So here the gradient of the line will be minus 4, because in front of that x is a minus 4. So the gradient of the line will be minus 4. If you wanted to, you could turn it around and write y equals, and we could write it in this form, y equals mx plus c. So mx would be minus 4x. And then plus c, well, we've got 3, which is positive 3, so it'd be plus 3. So that means that we could turn it around and write y equals minus 4x plus 3, and again the gradient would be negative 4. And that's it. So the gradient of that line is negative 4. Okay, let's look at our next question, question number 14. Okay, so question number 14, it says shown below are 4 straight line graphs. We've got graph A, graph B, graph C, and graph D. And then we've got this table here. And the table, we've got 4 possible equations. Y equals 3x plus 3, y equals 3x minus 3, y equals minus 3x plus 3, and y equals minus 3x minus 3. And we need to match each of the equations to the right graph. Now, whenever I look at these equations, what I notice is that we have got 2 of them with 3x and 3x, and 2 of them with minus 3x and minus 3x. So 2 of them have a positive gradient, so we'll be going up that way, and 2 of them have a negative gradient, so they'll be going down that way. Also, if we have a look at the y-intercepts, 2 of them have got a y-intercept of 3, so they're going to cross the y-axis of 3, and 2 of them have got a y-intercept of negative 3, so they're going to cross the y-axis at negative 3. So that's going to help us distinguish which one's which. So let's have a look at the first one, graph A. So this graph A, it's got a positive gradient. It's gone up that way, so it's got a positive gradient. So the gradient, if we have a look here, if we go across 1 unit, we got 3. So the gradient of that line is 3. So it's going to be y equals 3x. And it crosses the y-axis at 3. So it'll then be plus 3. So it's got a positive gradient and it crosses the y-axis of 3. So let's go down here and then figure out which one that would be. So y equals 3x plus 3 is the top one. So that's graph A. Okay, now let's have a look at graph B. Okay, so graph B, it's got a negative gradient this time. So the gradient of this line is going to be negative 3, goes across 1 and down 3, and it crosses the y-axis at 3. So this equation will be y equals minus 3x plus 3. It crosses the y-axis at 3, so it'll be plus 3, and it's got a negative gradient, so it's going to be minus 3x. So y equals minus 3x plus 3, that would be this one here, so that one's graph B. Okay, now let's have a look at graph C. Okay, now let's have a look at graph C. It's got a negative gradient, so it's going to be y equals minus 3x, because it's going down that way. And it crosses the y-axis at negative 3, so it'll then be minus 3. So let's have a look here. So y equals minus 3x minus 3, that'll be the bottom one there. And then graph D, if we have a look at it, graph D, and then in terms of graph D, it's got a positive gradient, so it's going to be y equals 3x, and it crosses the y-axis at negative 3, so it'll be minus 3. So that'll be y equals 3x minus 3. So that's going to be this one here. So the graphs would be A, D, B, and C. And that's it. And we use the fact that some of them had positive gradients to help us distinguish which ones had positive gradients and which ones had negative gradients. And we also looked at where it crossed the y-axis. So in other words, would it be plus 3 or would it be minus 3? Okay, let's look at our next question, question number 15. Okay, let's look at our next question, question number 15. So question number 15 says a straight line is drawn below. So we've got this straight line, and it goes through the origin, the point 0, 0, and it goes through the point 642, because this is the point here, 642. And we've been asked to write down the equation of this line, so we need to write down the equation of that line. It's a straight line, so it's going to be in the form y equals mx plus c. It crosses the y-intercept at 0, so here we know it passes through the origin, so in terms of the plus c, that's going to be 0. And you tend not to write plus 0, so it would just be y equals mx, this graph. It won't have a plus anything on the end because it passes through the y-axis at 0, the origin. So instead of writing plus 0, we just don't write anything. Now we need to find the gradient of the line. If we can find the gradient of the line, that would be what m is. So it'll be y equals something x, and that'll be its equation. So let's find the gradient. So let's do a little right angle triangle, because we know it passes through the origin and it passes through the point 6, 42. So in terms of the run, it's going from 0 across to 6, so the run would be 6. And in terms of the rise, it's going from a height of 0 up to a height of 42, so the rise would be 42. So we're going to do the gradient is equal to the rise divided by the run. So the rise is 42 divided by the run, which is 6, and 42 divided by 6 is 7. So the gradient of that line is 7. If you start off at the origin and you go across 1, you'd go up 7, across 1, up 7, across 1, up 7, and so on, and you'd get to 642. And that's it. So the equation of that line is y equals 7x. And that's it. Okay, let's look at our next question, question number 16. So question number 16 says, work out the gradient of the line y plus 7x equals 8. Now before we do this question, it can be quite useful to look at a topic called change in the subject, particularly if you want to find the gradient of a line or even the y-intercept of a line. If you can rearrange it to be in the form y equals mx plus c, that can be really, really useful. So if you go to Corbettmaths and go to the videos and worksheets section and scroll down to change in the subject, that'd be a really useful video for you. Okay, so if we want to work out the gradient of this line, what I'm going to do is I'm going to rearrange it to be in the form y equals mx plus c, because then we can just look at it straight away and see what the gradient is. So here we've got y plus 7x equals 8. We want to get the y on its own, so we don't want this 7x here. So what I'm going to do is I'm going to take away 7x from both sides of the equation. So I'm going to take away 7x from the left-hand side, and I'm going to take away 7x from the right-hand side. So on the left-hand side, we had y plus 7x. We're taking away the 7x to get rid of the plus 7x, we'll just be left with y. So that's fantastic. Then we're going to have our equal sign. Now, in terms of the right-hand side, we could do 8 subtract 7x and write 8 subtract 7x if you wanted to. I'm actually going to put the minus 7x in front, so I'm going to write minus 7x first of all. And then we had the 8, which was positive, so I'm then going to write plus 8. You could, if you wanted to, as I mentioned, write down 8 minus 7x, and that's fantastic as well. And then if we want to find the gradient of the line, we can just have a look here and see what's the number in front of the x, and it's minus 7. So it means the gradient of the line is minus 7. And that's it. So being able to change the subject can be really, really useful whenever you want to write down the gradient of a line if the equation has been given to you in a form that's not the form y equals mx plus c. Okay, let's look at our next question, question number 17. Okay, so question number 17 says a line has got the equation 3x plus y equals 15. And part A says find the gradient of the line, and part B says find where the line crosses the y-axis. Okay, so part A says find the gradient of the line. So if we have a look at this equation, 3x plus y equals 15. Y is not the subject. We've got this 3x here as well. So let's get rid of this 3x. So I'm going to write down 3x plus y equals 15. I want to get the y on its own, so I want to get rid of this 3x. I'm going to minus 3x from the left-hand side. I'm going to minus 3x from the right-hand side. On the left-hand side, we're taking away 3x to get rid of this 3x. We'll just be left with y. And then on the right-hand side, we could write 15, take away 3x. But I'm actually going to put the minus 3x at the front, so minus 3x, and then the 15 is positive, so then plus 15. And that's fantastic because we've now got it in the form y equals mx plus c. If you did write it as y equals 15 minus 3x, you can still look and see 15 is the y-intercept and minus 3 is the gradient, but I just prefer it in that format. And then part A says find the gradient of the line. So the gradient of the line is going to be the number in front of the x, so it's going to be negative 3. So the gradient of that line is negative 3. And then part B says write down where the line crosses the y-axis. So we can see the y-intercept is 15, so it's going to cross it at 0, 15. So 0 across, 15 up. And that's it, that's where it's going to cross the y-axis. Okay, let's look at our next question, question number 18. So question number 18, we've been given this grid and we've got this line drawn on the grid, and we've been asked to find the equation of the line. So we want to find the equation of that line. So it's a straight line, so it's going to be in the form y equals mx plus c. So its equation is going to be in the form y equals mx plus c. And we want to find its gradient, and we want to find the y-intercept. So let's start up and find the gradient of the line. So I'm going to choose 2 points on the line. So I'm going to choose here the point -1, -16. I'm going to choose the point here, 1, 8. So here we've got the point 1, 8 there. Okay, so we've got the points -1, -16, and 1, 8. So we want to find the gradient of that line. So let's make a little right angle triangle, or in this case, quite a large right angle triangle. Okay, so in terms of the run, we're going from -1 to 1. So the run is just 2. So we're going 2 units across. And in terms of the rise, we're going from a height of negative 16 up to a height of 8. So the rise would be, we're going up 16 and then another 8, so that'll be 24. So the rise would be 24. So the gradient m would be equal to the rise, which is 24, divided by the run, which is 2. And 24 divided by 2 is 12. So the gradient of that line is 12. So it's going to be y equals 12x. Then to get the plus c part, we just need to find the y-intercept of the line, and that will be negative 4. So it's going to be minus 4. So it means the equation of that line is y equals 12x minus 4. Okay, let's look at our next question, question number 19. Okay, let's look at our next question, question number 19. So question number 19, we've been given the equation of a line, y equals minus 2x plus 6. And part A is we want to find the coordinates of the point where it crosses the y-axis, and part B is where we want to find where that line, the coordinates of the point where that line crosses the x-axis. So to find where a line crosses the y-axis, you let x equal 0. So you let x equal 0. So to find where a line crosses the y-axis, x equals 0, because if you think about it, it's 0 across. So to find where it crosses the y-axis, you're going 0 across, so x would be equal to 0. So if you just substitute that into the equation, so we're going to have y is equal to minus 2 times 0, so minus 2 times 0, and then we've got plus 6. Minus 2 times 0 is 0, and then so we have that y is equal to 0 plus 6, and 0 plus 6 is 6, and that's it. And if you think about it, the y-intercept would have been 6, so that's where it crosses the y-axis, 6. But if you want to find where a graph crosses the y-axis, you just let x equal 0. So it's going to cross the y-axis at the point 0, 6, 0 across, 6 up, and that's it. Okay, and then in terms of part B, we want to find the coordinates of the point where the graph crosses the x-axis. So where a graph crosses the x-axis, y equals 0, the height is equal to 0. So we had y equals, I'm just going to write down, y equals minus 2x plus 6. But we know the height's going to be 0, so we know that y is equal to 0. So we can have 0 is equal to minus 2x plus 6. And then if we solve this equation, we can then find out what x is, and that'll then be where it crosses the x-axis. So that's going to be, if we add 2 x's to both sides, we're going to get, if we add 2 x's to the left-hand side and add 2 x's to the right-hand side, we're going to get that 2x equals, and then minus 2x plus 2x is 0, so we're just left with 6. So we've got that 2x equals 6, and then if you have both of those, you get that x equals 3. So that means it crosses the x-axis at 3. So that'll be 3, 0. And that's it. So if we want to find where a graph crosses the y-axis, you let x equal 0. And if you want to find where it crosses the x-axis, you let y equal 0. And that's it. Okay, let's look at our next question, question number 20. Okay, so question number 20, we've got a line with equation 6x plus 2y plus 9 equals 0. And part A says find the gradient of the line. That's a calculator question, so if we need a calculator, we can grab one of those. Okay, so we've got this equation, and it's not in the form y equals mx plus c. And I like it to equal y equals mx plus c. So what I'm going to do is I'm going to rearrange this and make y the subject so that we can find the gradient of the line really quickly and easily. So we have 6x plus 2y plus 9 equals 0. We want to make y the subject, so let's take away 6x from both sides. So let's take away 6x, so from the left-hand side and from the right-hand side. 6x, take away 6x is 0, so we're going to be left with 2y plus 9 on the left-hand side. And the right-hand side, we're going to be left with minus 6x, because we're 0 and we're taking away 6x, so that's minus 6x. Now we want to find out what y is, so let's get rid of this 9. So let's take away 9 and take away 9. So then on the left-hand side, we'll be left with 2y. And on the right-hand side, we'd have minus 6x minus 9. And finally, we don't want 2y, we just want y, so let's divide everything by 2. And if we divide everything by 2, we're going to get that y, because half of 2y is y, is equal to, and if we divide all of this by 2, minus 6x divided by 2 would be minus 3x, and minus 9 divided by 2 would be minus 4.5. I could have written it as a fraction 9 over 2, but that's fine. And part A says write down the gradient of the line. So here, we've got it in the form y equals mx plus c, so the gradient will be minus 3, and that's it. Okay, and then if we have a look at part B. Okay, so part B says find where the line crosses the y-axis. So we've got y equals minus 3x minus 4.5. Where it crosses the y-axis is the y-intercept, so that's just going to be this part, the c part. So it's going to be minus 4.5, so it's going to be 0, then minus 4.5, and that's it. That's the coordinates of where it crosses the y-axis. If you wanted to, you could go back up to the original equation, which is 6x plus 2y plus 9 equals 0. And if you want to find out where it crosses the y-axis, you let x equal 0. So x would be equal to 0. So this part here would just be 0. 6 times 0 is 0. So we'd be left with 2y plus 9 equals 0. Take away 9 from both sides to get that 2y equals minus 9. And divide by 2 and you get y is equal to minus 4.5. And then it'd be 0 minus 4.5. And that's it. Okay, let's look at our next question, question number 21. So question number 21, we've got the equations of 4 lines. We've got line A, which is y equals 4x plus 1. Line B, which is y plus 2x equals 8. Line C, which is y equals 9 minus 2x. And line D, which is y minus 3x equals 3. And the question says, which lines go through the point 2, 9? So if we want to find out which lines go through the point 2, 9, I'm going to substitute these values into each of the equations. So here we've got a point with the x coordinate is equal to 2. Remember, the x is along the corridor, so it comes first. So the x coordinate is equal to 2, and the y coordinate is equal to 9. So we've got the x equals 2 and y is equal to 9. So if we substitute those into the equations, we'll be able to figure out which lines this point lies on. So let's start off with line A. So line A is y equals 4x plus 1. So y is equal to 4x plus 1. So y, which is 9, is equal to 4 times the x coordinate. So 4 times 2 plus 1. And let's work this out. 4 times 2 is 8. So we get that 9 is equal to 8 plus 1. And 8 plus 1 is 9. So we get 9 is equal to 9. So that means that 2, 9 does lie on line A. So it does lie on line A. So one of the lines is line A. Okay, let's now have a look at line B. Okay, so line B is y plus 2x equals 8. So y is equal to 9 plus 2x, that's 2 times 2, which is 4, and that's equal to 8. 9 plus 4 is 13, and that does not equal 8, so it does not lie on line B. In terms of line C, we've got that y is equal to 9 minus 2x. Let's substitute those points in. So y, that's 9. So 9 is equal to 9 minus 2 times x. That's going to be 2 times 2. 2 times 2 is 4. So we get the 9, and then that does not equal 5. So that means that it does not lie on line C. And let's have a look and see if it lies on line D. So line D, we've got the y minus 3x equals 3. So y, that's 9, minus 3x, that's 3 times 2, which is 6. And is that equal to 3? And that does equal 3, so yes. So that means that the line D also passes through the point 2, 9. So which lines go through the point 2, 9? That's going to be line A and line D. And that's it. Okay, let's look at our next question, question number 22. So question number 22, we're told that the line L passes through the point 0, 7 and 3, 19. And we've been asked to work out the equation of the line L. So it can be very important to be able to work out the equation of a line that passes through 2 points if you've just been given the coordinates of those points. So rather than be given a grid or a set of axes with a line drawn on it, just to be able to find the equation of the line that passes through those points without that grid drawn for you. So what I'm going to do is I'm going to do this question using 2 different approaches. And I'm going to use one approach which doesn't use any sketches or grids at all, and then I'm going to use a second approach which uses a sketch. So let's start off by writing down the equation of the line. The equation of the line is going to be in the form y equals mx plus c. So y equals mx plus c. Okay, so we want to find the equation of this line. So to find the equation of the line, we want to find the gradient of the line and the y-intercept. So let's start off by finding the gradient. So we want to find the gradient of the line that joins these 2 points. And again, if you go back to Corbettmaths and watch the videos on gradient, there's a video on how to find the gradient between 2 points, and you use a formula, and the formula is m, the gradient, is equal to y2 minus y1 over x2 minus x1. This will tell us the rise and the run. So let's label the points x1, y1, and x2, y2. So that's your first point, so it's x1, y1, and your second point, x2, y2. And we're going to substitute those values into this formula, and it will tell you the gradient of the line. So y2, that's 19, subtract y1, that's 7. That will tell us our rise, because we're going from a height of 7 up to a height of 19, so it'll be a rise of 12, and this will be 12, divided by y2 minus y1, so it's going to be 3 subtract 0, so 3 subtract 0, and that's our run there. 3 subtract 0 is 3, and if you notice here the run is 3. So 19 take away 7 is equal to 12, and 3 take away 0 is equal to 3. So we've got 12 divided by 3, and that's equal to 4. So the gradient of the line passing through these points would be 4. And let's just check that. If the line that passes through this point has a gradient of 4, it would go across 1 and up 4, so that'd be 1, 11. Across another 1 and up another 4 would be 2, 15. And then across 1 and up another 4 would be 3, 19. So yeah, that would work. So that means the gradient is equal to 4. So it's going to be y equals 4x. Now we have to find the plus c. Now this question is very, very nice because it goes through the point 0, 7. So we're told it goes through 7 on the y-axis. So the y-intercept is 7. So it's just going to be plus 7. So that means the equation of that line would be y equals 4x plus 7. And that's it. So that was one approach to just learn the formula y2 minus y1 over x2 minus x1. Alternatively, as I mentioned, you could do a sketch. So you could just get a ruler and say, well, the point 0.7 would be there somewhere. 319 would be further across and up a bit higher, so up there somewhere. And you could just do a little sketch of that line like so and say, well, this is the point 0.7. This is the point 319. And to get from here to here, you could do a little right angle triangle and then do the run and the rise. We're going across 3, so the run is 3, and the rise would be 12 because we're going from a height of 7 up to a height of 19, so the rise would be 12, and then we could do 12 divided by 3, which is equal to 4. So you do a little sketch just thinking where the coordinates would be in relation to each other. So we just plotted this one anywhere, and this one will be further to the right and further up, so we've gone across the right and up a bit, and I've just done a little sketch. Okay, and that's it. That's question number 22. Let's have a look at question number 23. So question number 23, part A says, write down the gradient of the straight line with equation y equals 8x plus 2. Well, that's quite nice. It's in the form y equals mx plus c, and you can see the m, the gradient, is going to be equal to 8, so the gradient would be 8. Okay, then we're told the line crosses the y-axis at the point A, and we've been asked to write down the coordinates to that point A. Okay, so where it crosses the y-axis is the y-intercept, and if we look at the equation, it's y equals 8x plus 2. So the y-intercept is 2. So that means that across the y-axis is 2, the y-intercept is 2, so it's going to be the point 0, 2. 0 across, 2 up. And then part C says the line crosses the x-axis at the point B. Write down the coordinates of the point B. So it's y equals 8x plus 2. That's the equation of the line. And we want to find where it crosses the x-axis. So to find where it crosses the x-axis, y is equal to 0. So if we let y equal 0, we're going to have 0 equals 8x plus 2. So 8x plus 2. And then if we solve that, we can find the x-coordinate of the point B. And we'll know the y-coordinate is 0 because we know the height will be 0. So let's solve this. So let's take away 2 from both sides. So let's take away 2 from the left-hand side and take away 2 from the right-hand side. So on the left-hand side, we'll have negative 2. And on the right-hand side, we'd have 8x. Okay, so we've got the minus 2 is equal to 8x. We want it just to be x, so we don't want this times by 8 here. So let's divide by 8 and divide by 8. So then we're going to have minus 2 divided by 8. And I can just write that as a fraction. So minus 2 divided by 8. And then the right-hand side, we've got 8x divided by 8. That's just going to be equal to x. So minus 2 divided by 8 will be minus 2 over 8. Now minus 2 over 8, we can cancel that down. That'll be minus a quarter. So it means that x is equal to minus a quarter. So that means that the x-coordinate of where it crosses the x-axis, so of the point B, would be minus a quarter. So it's going to be minus a quarter. And then the y-coordinate would just be 0 because we know that the height would be 0. And that's it. So that means the coordinates of the point B would be minus a quarter, 0. Okay, let's look at our next question, question number 24. Okay, so question number 24, we've got a line that passes through the points D, which have got coordinates -9, 4, and the point E, which is -1, 20. And so we've got that line, and part A says find the gradient of the line. So we want to find the gradient of the line. Now, a sketch has been drawn for, so we may as well use it. So let's do a little right angle triangle. So going across to get the run, and then up to get the rise. So the run, we're going from -9 to -1, so we're going across 8 there. And then in terms of the rise, we're going from a height of 4 up to a height of 20, so the rise would be 16. So we've got a run of 8 and a rise of 16. So the m, the gradient, would be equal to 16 over 8, the rise divided by the run, which would be 2. So the gradient of that line is 2. So the gradient of that line is 2. So we've done part A. Part B says find the equation of the line. So we know it's going to be in the form y equals mx plus c. We know the gradient is 2, so it's going to be y equals 2x, and we need to find out c where it crosses the y-axis. So let's go back up. Now, there's a few different ways we can do this, and I'm going to show you two different approaches now. One approach is actually to use a bit of common sense. The gradient of the line is 2. So if we go across another 1 and then up 2, would be the point 0, 22. Because if we go across 1, we're at 0, and up 2 would be 22. So it's going to cross the y-axis at 22. That's going to be the y-intercept. So that means it crosses the y-axis at 22. So that means that the equation would be y equals 2x plus 22. So that's the equation of the line. Y equals 2x plus 22. So that's one approach, and that was quite a nice question because we had a sketch drawn for us and the point was really, really close to the y-axis, and we could just go one across and figure out what the y-intercept would be. But what if the point was this one and another one? That one's a bit further away from the y-axis, so it'd be a little bit trickier to figure it out. So let's have a look at another way we could do it, and this would be quite a general way which I would use quite a lot. So if we had y equals, now we knew the gradient was equal to 2, so 2x, and then we had plus c. Now if we go back to this point where we knew the gradient was equal to 2 and we wanted to find y across the y-axis, another approach would be to just write this down, y equals 2x plus c, and then find a point that the line passed through. So the line passed through the point negative 120. We could choose negative 94, but I'm going to choose negative 120 just because I think it's going to be a little bit easier to use those numbers, but you could choose this one, any point that the line passes through. And then if you go back down here, we had, I'm just going to write it down here, negative 120. We had that, and we know that it passed through that point. So what I'm going to say is, well, the x-coordinate is equal to negative 1 and the y-coordinate is equal to 20. And we can substitute those into this equation and find out what the value of c is going to be. So y, that's 20, is equal to 2 times x, that's going to be 2 times a negative 1, so 2 times negative 1. And then we've got plus c. 2 times negative 1 is negative 2, so we've then got that 20 is equal to negative 2 plus c. And we want to find out what c is. I'm just going to go down a little bit. We want to find out what c is, so let's get rid of this negative 2 by adding 2 to both sides. So if we add 2 to the left-hand side and add 2 to the right-hand side, we'll get that 22 is equal to c. So c is equal to 22. So that means that we know that the y-intercept is equal to 22, so the equation would be y equals 2x plus 22. And that's it. Now in terms of this question, our first approach was to use common sense and just to figure out if we go across 1 and up 2, we know across the y-axis is 22. Another approach is to write down y equals mx plus c, put in the value for m that you know, and then find a point that it passes through and substitute that in. There is another approach. Some teachers use this formula, y minus y1 is equal to m bracket x minus x1. That's another way you can work out the equation of the line if you know the gradient and a point it passes through. I tend to just use that approach, but it's up to you. Okay, and let's have a look at our next part. Part C. Part C says, does the line pass through the point with coordinates 12, 44? So 12, 44. And I've just written x and y above them there. So let's substitute those values in. So y, that's 44. Does it equal 2 times x, so 2 times 12, and then add 22. So 2 times 12 is 24, so you get that 44 is equal to 24 plus 22. And that would be 44 is equal to 24 plus 22 is equal to 46. Well, that's not equal to it. So no, it doesn't lie on the line, so no. As written down, no, it does not lie on the line because obviously that doesn't work. If that worked and we got something such as 44 equal to 44, then you would know it lies on the line, but here it doesn't. Okay, let's look at our next question, question number 25. Okay, so question number 25, we've got this grid and we've got this line, and part A says find the equation of the line. So we want to find the equation of this line. So we know the y-intercept is 16, that's quite straightforward, but let's find the gradient of the line to begin with. So I'm going to choose this point here, the point 112, so the point 112, and I'm going to choose this point here, the point 34, so the point 34. And let's find the gradient of the line. So if we go across, let's get the run on the rise, we go across, and then we go down. And in terms of the run, we're going from 1 to 3, so the run would be 2, we're going 2 across. And then in terms of the rise, we're going from height of 12 down to height of 4, so the rise would be negative 8. So that means the gradient m will be equal to the rise, which is negative 8, divided by the run, which is 2, and negative 8 divided by 2 is negative 4. So the gradient of that line is negative 4. So let's go down here. We've got, write down the equation of the line, so it's going to be y equals negative 4x. Now we want to find out the value for c, so that's the y-intercept, and if we go back up, you can see here that the y-intercept is equal to 16. So it's going to be y equals negative 4x plus 16, and that's it. Okay, and then part B. Part B says, find the y-coordinate of the point on the line with an x-coordinate of 8. Now, we can't carry on the graph here. Well, you could if you wanted to and try and draw a set of axes big enough to have that graph on it. So what we're going to do is we're going to use the equation. We've got y equals minus 4x plus 16. So to find the y-coordinate, we do minus 4 times the x-coordinate plus 16. So if the x-coordinate is equal to 8, we're going to do y is equal to minus 4 times 8. So minus 4 times x, minus 4 times 8. And then we're going to add 16. Okay, so y equals minus 4 times 8 would be minus 32. So minus 32, and then we've got plus 16. And minus 32 plus 16 would be minus 16. So then we'd have the y-coordinate is minus 16. So if the x-coordinate is 8, the y-coordinate would be minus 16. So the answer is minus 16. And that's it. Okay, let's look at our next question, question number 26. So question number 26 says, find the equation of the line that passes through the points negative 3, 5 and 1, negative 15. So we want to find the equation of the line that passes through those points. So what we want to do is, well, it's obviously the equation of a line, so it's going to be in the form y equals mx plus c. And we want to find the gradient of the line that passes through these 2 points. So let's use the formula m is equal to y2 minus y1 over x2 minus x1. So the first point would be x1, y1, and the second point would be x2, y2. And if you use that formula, you can find the gradient of the line that passes through those points. So let's do that. So we'd have y2, that's equal to, m is equal to y2, which is minus 15, and then minus y1, so it'll be minus 5, over x2, that's going to be 1, and then minus, and then x1, which is minus 3. So we've got 1 minus minus 3 there on the denominator. Minus 15 minus 5 would be minus 20, divided by 1 minus minus 3 would be 4. So we've got minus 20 divided by 4. And minus 20 divided by 4 will be equal to minus 5. So it means the gradient of the line passing through these points would be negative 5. Okay, so we now know the gradient of the line, it's negative 5. We've got y equals minus 5x plus c. Now we want to find c where it crosses the y-axis. And we could use this point here and think, well, if it passes through the point 1, negative 15, and it's got a gradient of negative 5, if we go back across 1 and up 5, we'd know it passes through the y-axis at minus 10. So we could use that approach if we want to do. But what I'm going to do is I'm going to substitute the coordinates of one of these points into that, and we'll find out the value for c. So let's do that. And I'm going to choose this one here, 1 minus 15. I could, if I wanted to, choose minus 3, 5. That's fine as well. So y, that's going to be minus 15, is equal to minus 5 times x, that's minus 5 times 1, which is minus 5, plus c. Now we want to get the c on its own, so we want to get rid of this minus 5, so we're going to add 5 to both sides of the equation. And if we add 5 to the left-hand side, minus 15, plus 5 will be minus 10. And then on the right-hand side, if we've got minus 5 plus 5, that's 0, so we're just left with c. So c is equal to negative 10. So we found the value for m. The value for m is minus 5, and the value for c is minus 10. So that means the equation would be y equals minus 5x minus 10. So that's the equation of the line that passes through those points. And that's it. Now there were other ways to approach that question. We could have done a sketch and found the gradient using the sketch. We could have used the formula y minus y1 equals m bracket x minus x1 for finding the value for c. But I've used that approach. I've used that formula y2 minus y1 over x2 minus x1 to find the gradient. And then I've just put that gradient into y equals mx plus c, substituted in the x coordinate and the y coordinate from one of the points that we know the line passes through into that y equals mx plus c, found the value for c, and then we've written down the equation. Y equals minus 5x minus 10, and that's it. Okay, so question number 27, we're told that the point A, 1, 1, and the point B, 5, negative 1, lie on the line L, and we've been asked to find the equation of the line L. So we want to find the equation of the line that passes through these points. So again, let's find the gradient, because we know it's going to be in the form y equals mx plus c. So in terms of finding the gradient of the line, what I'm going to do is I'm going to consider these 2 points, and we've got this point A, which is 1, 1, and I'm going to call that x1, y1, and we've got the point B, which is x2, y2. And we're going to use the formula m, the gradient of the line, is y2 minus y1 over x2 minus x1. So let's substitute those values in and find the gradient of the line. So y2, that's negative 1, subtract y1, which is 1, all divided by x2, which is 5, minus x1, which is 1. And then if we work that out, we get that m is equal to minus 1 take away 1 would be minus 2, and then 5 minus 1 would be 4. And then we're left with minus 2 divided by 4. Well, that would mean that the gradient would be equal to minus. And then 2 over 4, if you cancel that down, that's going to be equal to a half. So it means the gradient of the line is equal to negative a half. So that means that the equation of the line will be y equals minus a half x plus c. Now to find the value of c, the y-intercept, what I'm going to do is I'm going to choose one of these points. I'm definitely going to choose point A here, it's just a bit easier, 1, 1. And I'm going to substitute in those values for x and y. So in terms of y, that's going to be 1, and that's equal to minus a half times 1, that's going to be minus a half. And then we've got plus c. And then if we add a half to both sides, that'll get rid of this minus a half, so that'll be 1.5, because 1 plus a half is 1.5, or 3 over 2, or 1.5, and that's equal to c. So that means the y-intercept is equal to 1.5. So that means the equation of the line, if we put that back in, the equation of the line y will be equal to minus a half x, then plus 1.5, or 1.5, or 3 over 2. That's going to write 1.5, and that's it. That's the equation of the line L. Okay, let's look at our next question, question number 28. So question number 28 says a line has got a gradient of 8 and passes through the point 2, 3. And we've been asked to find the equation of the line. So we know the gradient of the line is 8, so that means that it's got y equal, so that means its equation is y equals mx plus c. And if we replace m with the gradient of 8, we get y is equal to 8x plus c. Now if we want to find the value of c, we can just substitute in those values, that x is equal to 2 and y is equal to 3. because we know that the line passes through that point. So if we substitute those into this equation, we can find out what c is, and then know what the y-intercept is, and then know the equation of the line. So y, that's going to be 3, is equal to 8x, that's 8 times 2, which is 16, plus c. And then if we take 16 away from both sides, that's going to give us 3 take away 16 will be minus 13, is equal to c. So c is equal to minus 13. So that means the equation of the line would be y is equal to 8x minus 13. And that's it, that's the equation of the line. Okay, let's look at our next question, question number 29. Okay, so question number 29 says a straight line passes through the point 1, 3 and has got a gradient negative 4. We've been asked to find the equation of the line. So the equation of the line will be y equals mx plus c. And we know the gradient of the line is a negative 4, so we've got y is equal to negative 4x plus c. In terms of the line, we know it passes through the point 1, 3, and the x-coordinate there would be 1 and the y-coordinate would be 3. And if we substitute those in, we can find the value for c, the y-intercept. So y, that's equal to 3, is equal to negative 4 times 1, that's going to be minus 4, then plus c. Now if we want to get the c on its own, we want to get rid of this minus 4, so we're going to add 4 to both sides. So then we get that 7 is equal to c. So it means that y-intercept is equal to 7. So we can put that in and get that the equation of the line would be y is equal to minus 4x plus 7. And that's it, that's the equation of the line. Okay, let's look at our next question, question number 30. Okay, let's look at our next question, question number 30. So question number 30 says a line's got a gradient of negative a half and passes through the point negative 6, negative 8. And we've been asked to find the equation of the line. So we know that the equation of a line is in the format y equals mx plus c. And we need to find m, the gradient of the line, which is minus a half. And we need to find c, the y-intercept. So we know the equation of the line is going to be y equals minus a half x plus c. And if we want to find the value for c, we're going to substitute in the point that the line passes through. So it passes through the point negative 6, negative 8. So the x-coordinate is negative 6 and the y-coordinate is negative 8. So if we substitute those in, we're going to get that minus 8 is equal to minus a half times minus 6. That's a calculator question, so you could do minus a half times minus 6 on your calculator, and you find that's equal to 3. Or you can just know that a negative times a negative is a positive, and a half times 6, well, half of 6 is 3. So it's going to be 3, then plus c. Now we want to find out what c is, so let's take 3 away from both sides. So on the left hand side, minus 8 take away 3 would be minus 11. And on the right hand side, we're left with c. So that means that c is equal to minus 11. So it means the equation of the line will be y equals minus a half x, and then we've got minus 11. And that's it, that's the equation of that line. Okay, let's look at our next question, question number 31. Okay, so question number 31 says a line has got a gradient of negative 4/5 and passes through the point 30, 24. And we've been asked to find the equation of the line. Okay, so we know it's in the form of y equals mx plus c. We know the gradient's minus 4/5, so let's write down minus 4/5 x plus c. We want to find out what c is, which is the y-intercept, so let's substitute in the point that the line passes through. It passes through the point 30, 24, so that's the x-coordinate is 30 and the y-coordinate is 24. And let's substitute those in. So y, that's 24, is equal to minus 4/5 multiplied by 30, and then plus c. Now here we got minus 4/5 times 30. It's a calculator question, so you can type that into the calculator if you wanted to. Or another way to do it is to just go, well, a negative times a positive will be a negative, and let's work out what 4/5 of 30 is. So 30 divided by 5 is 6, times 4 would be 24. So that means that minus 4/5 times 30 would be minus 24. And then we've still got our plus c. Now we want to get the c on its own, so let's add 24 to both sides. So then if we add 24 to the left hand side, we'd get 48, and that's equal to c. So that's fantastic. We now know the equation of the line. It's going to be y equals the gradient minus 4/5 and then x, and then plus 48, and that's it, that's the equation of that line. Okay, let's look at our next question, question number 32. Okay, so question number 32 says the line with equation 4x plus 3y equals 36 crosses the y-axis at the point A. The line with equation y equals 2/3 x minus 12 crosses the x-axis at the point B. And the point C is the midpoint of AB, and we've been asked to find the coordinates of C. Okay, so what I'm going to do to begin with is I want to find where this graph 4x plus 3y equals 36 crosses the y-axis, and that's going to be the point A. So we want to find the coordinates of the point A. And to find A, well, to find where it crosses the y-axis, we let x equal 0. So if we've got 4x plus 3y equals 36, we're going to let x equal 0, and that'll tell us where it crosses the y-axis. So if we let x equal 0, 4 times 0 is 0, and then we're just left with the 3y, and that equals 36. And then if we divide by 3, we get y is equal to 12. So it means the coordinates of the point A will be 0, 12. So 0, 12. Okay, so that's A. Now let's find B. Okay, so the other line had equation y equals 2/3 x minus 12, and that crosses the x-axis at the point B. So it crosses the x-axis at the point B. So to find the coordinates of the point B, if it crosses the x-axis, we know that y is equal to 0. So let y equal 0. So let this y equal 0, so we're going to get the 0 is equal to 2/3 x minus 12. And then if we solve this equation, we'll know the coordinates of the point B. So if we add 12 to both sides, we're going to get that 12 is equal to 2/3 x. Then we could divide both sides by 2/3. And it's a non-calculator question, so what I probably would do is I'd probably times both sides by 3 to get rid of this divide by 3. So that would be times on both sides by 3 would be on the left-hand side, 36. And then the right-hand side would times it by 3 to get rid of the divide by 3, so we're just left with 2x. Then I would divide by 2 to get the 18 equals x. So x equals 18. So it means the point B is the point with coordinates 18, 0. So 18, 0. So that's fantastic. We now know the coordinates of the point A. We know the coordinates of the point B. The point C is the midpoint of AB. So we want to find the midpoint of those 2 points. So to find the midpoints of 2 points, you add them together and then half it. So we add the x coordinates together. So that'd be 0 plus 18. So 0 plus 18 and then divide by 2. And in terms of the y coordinate, it'd be 12 plus 0 divided by 2. Okay, 0 plus 18 is 18, divided by 2 is 9, so that'd be 9. And then 12 plus 0 is 12, divided by 2 is equal to 6. So the coordinates of C would be 9, 6, and that's it. Okay, let's look at our next question, question number 33. Okay, so question number 33. We've got these two lines on the grid, line A and line B, and the grid hasn't been labelled in terms of a scale. But if we go on down a little bit, we're told the equation of line A, so we're told the equation of this line is y equals 5x plus 40. So we know the equation of that line is y equals 5x plus 40, and we've been asked to find the equation of that line. Okay, so it would be really great if we knew what the scale was. So if we knew, for instance, in terms of line B, so the coordinates are perhaps that point, and then we'd be able to find out the equation of the line by just finding the equation of the line because we had no 2 points that it passes through. But we don't know the scale, so let's look at what we've been given. We've been told that the equation of line A is y equals 5x plus 40. The y-intercept is equal to 40. So if we go to the line A, the y-intercept here would be 40. So that means that's 40, 30, 20, 10, 0, minus 10, minus 20, minus 30. So we know in terms of line B, it crosses the y-axis at minus 30. So in terms of its equation, we now know the plus c part. It's going to be minus 30 on the end. Okay, so now that's fantastic. We now know where the line B crosses the y-axis. Let's find out where the line B crosses the x-axis. So let's find the scale for the horizontal axis, the x-axis. So let's find the coordinates of where the line A crosses the x-axis. And to find where line crosses the x-axis, you let y equal 0. So the equation was y equals 5x plus 40. We want to find where it crosses the x-axis, so we know the height of that line is going to be 0, so we know y is equal to 0. So we get the 0 is equal to 5x plus 40. Then if we take away 40 from both sides, we're going to get minus 40 is equal to 5x. And then if we divide both sides by 5, we're going to get that minus 8 is equal to x. So that means that this line crosses the x-axis at negative 8. So that's negative 8. So that's fantastic. We now know the scale. We've got 1, 2, 3, 4 boxes. That'll be minus 6, minus 4, minus 2, 0, and so on. So we know we're going to cross on 2's there. So that's fantastic because now we know if we look at line B, we know where it crosses the x-axis and where it crosses the y-axis. So we can find its equation. We can find the gradient of the line by doing rise divided by run, and we can also find the y-intercept. It's minus 30. So let's find the gradient of line B. So in terms of the gradient of line B, I'm going to choose 2 points. I'm going to choose that point, and I'm going to choose that point, and I'm going to make a little right angle triangle. So I'm going to go across, and then I'm going to go down. So in terms of the run, we're going from negative 4 to 0, so the run would be 4. And in terms of the rise, we're going from 0 down to minus 30, so the rise would be minus 30. So that means for the line B, the gradient m would be equal to the rise divided by the run, the rise divided by run. For that line, the rise is minus 30, and the run is 4. And if we do minus 30 divided by 4, that's equal to minus 7.5, minus 7.5. Because half of 30 is 15, and half of it again would be 7.5, and it'd be negative 7.5. So that means that we know the gradient of the line, B, we know where it crosses the y-axis, so we know its equation, y equals mx, so that's going to be minus 7.5x, and then minus 30. And that's it, that's the equation of that line. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on the equation of a line, or y equals mx plus c. If you need an extra help on this topic, if you go to Corbettmaths and go to the videos and worksheets section, you'll find videos 188, 191, 194 and 195 are really useful videos for you. Also, I highly recommend watching the videos on gradient, even changing the subject can be useful as well, and they'll be useful videos for you. But again, this video, we're going through the video solutions to the practice questions. I really hope you found it useful, and if you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.